Alright, y'all. Here's the review. I'm going to try to plow through this as quickly as possible while also giving each problem the amount of information it needs. Most important thing to think about at the beginning is just like whenever you get a whole bunch of text and stuff, just stop, slow down, and think like, what is it really asking? What am I combining? And if you're pulling something multiple times, like doing multiple people or like pulling marbles out of or whatever it is, if you're doing it multiple times, that's going to be multiplying. And once you get through that, you have a good chance, okay? So, first thing first is listing the sample space. Once again, our sample space is just all our possible outcomes, okay? So all possible outcomes is my sample space, okay? So what I'm going to look at is when I flip a coin and roll a die, what could I get, okay? So sample space with notation with the brackets, okay? Flipping a coin, I can either get a heads or tail, right? So let's say I get a heads on the first one, and I roll the die, I get a 1, okay? Or I could have gotten a tails and a 1, right? Or I could have gotten the heads again and a 2, or heads and or tails and a 2, and all the way up. Heads 3, tails 3, heads 4, tails 4. Heads 5, tails 5. You can't see anything I'm doing, but I'm writing. Alright, so all the way through that, okay? What I'm looking at is each possible combination. So I get heads 1, or I get heads 3, or I get tails 4, so on and so forth. Okay, and there's my sample space. If you notice, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different things. And that makes sense because our total possible number of outcomes, there's 2 choices for our coin flip, heads or tails. There's 6 possible die. We're doing multiple things, so we're multiplying. 2 times 6 equals 12. That's where our 12 outcomes come from, and we can list it out. Cool, moving on. Looking at our next thing, frozen yogurt, yada yada yada, blah 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 blah, bunch of words, okay? There's 6 different flavors, 10 toppings, and 3 syrups. How many possible froyo combinations possible if I make one of each selected, okay? So out of my 6 frozen yogurt, out of those 6, I have to choose one of them, okay? So I got 6 choices for my first thing. I got 10 choices for toppings, 3 choices for syrups. 6 times 10 times 3 is 180. That's my answer. Make sense? Cool. Number 3 is kind of tricky. Okay, so number 3 you have to think and like, all right, what's happening? Okay, this is more like those problems that we have at the end of the study guide that are like pulling without replacement. Okay, and so I have 15 groups that I have to do at the restaurant. Okay. I only have space for 3 of them. How many ways can I choose those 3 groups? Okay. Well, first of all, I'm going to pick one group, right? So when I pick my first group, I have a choice of 15 different groups, right? There's my 15. So I take that group, I go sit them down, they're out of the picture now. How many groups do I have left? I have 14 groups left, so my next choice is going to be 14 out of 14 different groups. I sit them down, come back. How many groups do I have left? I now have 13 groups left. Okay? And so whenever we do this, we're just going to multiply 15 times 14 times 13. 15 times 14 times 13 is 2730. And that's my answer. That's the number of different ways I can make these groups because I just multiplied the 15 times 14 times 13. Cool. This next problem is not a multiple choice question, is not multiple choice. It's a multiple part question. So I'm rolling a 6-sided die. Okay? What's the probability I roll a 4? Well, one of the rolls sides will be a 4, so that's 1 out of the 6 total die sides. So it's 1 out of 6, which is 0.167. Alright, probability of odd of the 6-sided die, 1, 2, 3, 4, 5, 6. 3 of them, 1, 3, and 5 are odd. So there's 3 possibilities for me out of 6 total. 3 out of 6 is 0.5. Okay. Probability of number less than 5. There are 4 numbers less than 5. 1, 2, 3, 4. 4 numbers less than 5. Okay. So that's 4 positive outcomes. 4 positive outcomes out of 6 total outcomes. That is 0.667. Finally, probability of 8. Have any of you ever rolled a die that wasn't a dungeon? Ooh. I need to slow down, y'all. I'm sorry. So, have any of you ever rolled a die that wasn't a Dungeons and Dragons die and gotten an 8? I don't think so. The options are 1 through 6. There's 0 possible outcomes where we can get an 8 out of 6. Gives our 0. Cool. One thing is, if you're just like watching me solve these, you're not getting as much out of it. Okay, so make sure you're trying each of these on your own. Even if you try a problem, then watch me do it. And try a problem, watch me do it. Cool. All right. So, this one. A bag contains 4 basketballs, 6 footballs, 3 baseballs, 2 trumpets, 2 soccer balls, and 6 volleyballs. PE teacher selects an item at random. Find the probability that it is either a basketball or a volleyball. Okay? So with this, you can think of it, whenever I'm going to think about this, I'm going to think about the probability of getting a basketball. Okay? This BA for basketball. It doesn't, whatever. Basketball. Plus the probability of a volleyball. Okay? Minus the probability that I pull a basketball and a volleyball. That's intersect volleyball. Okay? So probably I pull one that's both. Okay? The probability of a basketball, there's 4 basketballs. Volleyball, there are 6 volleyballs. How many do we have that are both a basketball and a volleyball at the same time? None of them. So this is our chance where we have like a mutually exclusive, where they're not overlapping, so you don't even need this. You just cover it up and ignore it, but we put it in there because we can. So 4 plus 6 equals 10. The total number of items is 4 plus 6, 10, 13, 14, 15, 16, 17, 23. So 10 out of 23 equals 0.435. That's our probability. Cool. Number 6 is going to be done the same way. All right. In Miss Hoyt's math class, there are 17 boys and 11 girls. On a Unit 4 test, 4 boys and 5 girls made an A. If a student is chosen random class, what is the probability of choosing a boy or an A student? So probability of boy or A. Okay? Boy or A. Boy union A. Okay? So our union formula is going to be probability of a boy plus probability of an A minus probability of boy intersect A. Alright, so probability when they're both, okay? So my boys, I got 17 boys. Okay? My A students, I have 4 boys and 5 girls who made an A, so that's 9 total A students. Minus the ones that are both boys and A's, because we're double counting them right now, okay? So, minus 4 boys, that also got an A, minus the 4. That gives us 17 plus 9 minus 4 is 22. There are a total of 28 people in the class. I did that by adding up our boys and girls. Okay, so 22 divided by 28 is 0.786. And that's our answer. Alright, number 7, same exact problem as the last 3. Okay? A man randomly chooses a shape from the box. What is the probability that the shape is a star or an arrow? We have 1, 2, 3, 4, 5, 6, 7 stars. Plus 1, 2, oh, those aren't arrows, those are triangles. 1, 2, 3, 4 arrows. Minus 0 that are both a star and an arrow. Gives us our 11 out of a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 18? 18 shapes? 11 out of 18. 11 divided by 18 is 0.61. 0.611. That's our answer. Cool. Halfway there. All right, you toss a fair coin 3 times. Fair coin just means it's going to land on heads and tails the same amount of time. All right, so once again, we're doing a probability, and we're doing something multiple times. We're doing 3 tosses, right? So we're doing something multiple times, so we're going to multiply. So we have to look at it. What's the probability that the first will result in tails? Because we need all 3. So probably the first will result in tails. It's going to be 1 out of 2. So it's 50-50, right? Then probably the second will result in tails, times probably the third will result in tails. Okay, 1/2 times 1/2 times 1/2 is 1 out of 8, which is 0.125. Cool. Number 9 helps us out a little bit because it starts us off by asking how many balls are in the bag. We got 4 plus 3 plus 5 plus 3 golf balls. Okay, so that's 9 plus 6, 15 balls in the bag. Awesome. So, this is an example of what you need to do whenever you see these special words, okay? 2 balls are drawn with replacement. That's a buzzword. That's a word that you'll see, and we got to do something with that, okay? With replacement means we're putting everything back. We're not changing anything. We're just leaving it alone. Everything should end up exactly how it is at the beginning, okay? So, we're drawing two balls, okay? On our first draw, all right, we're drawing the first ball. We want to see if it's red. All right, so we have 4 red balls, okay? So we're going to put a 4 out of the total is 15. That's our first draw. Now, because we put the ball back in the basket, all right, then our second draw is also going to be a 4 out of 15 because it's the same probability because everything's still in the exact same space as it was. So 4 over 15 times 4 over 15, multiply across, 4 times 4 is 16. 15 times 15 is 225. 16 divided by 225 is 0.071. Cool. Blue and black is going to be the exact same thing. So the probability of a blue ball is 3 out of 15. Then we put everything back, so it's still the exact same, times the probability of a black ball is 5 out of 15. So that's the same as 1/5 times 1/3. Right? 1/5 times 1/3, which is 1 over 15, which is 0.067. Cool. Once again, because we're doing it with replacement, the probabilities of each type of thing doesn't change. Alright, moving along. Let's not scroll up too much because we need to see our problem still. Sorry if I'm getting wacky over here with the angles. But yeah, alright, now we're drawing without replacement. Without replacement, especially alarm bells should go off in your head and saying, wow, something's weird, we need to check on this. Okay, so probability that both the balls we draw are white. So just take this one at a time and then know you're going to multiply them because they're doing multiple things. All right, so probability we get a white ball first. There are 3 white balls out of the 15, right? So 3 out of 15. So we've taken that golf ball and we've set it aside. Now, we're going to pull out another golf ball from this basket. Okay? This second golf ball, how many golf balls are still in the bag? Well, remember, we pulled one out. So now there's only 14 golf balls in the bag, right? And because we've pulled a white ball already out of the basket, now there are only 2 white balls possible. So it's going to be 3 out of 15 times 2 out of 14. Because the number of white balls went down and the number of total balls went down. So that's the same as 1 out of 5 times 1 out of 7, which gives us 1 out of 35. 1 out of 35 is 0.029. Cool. Part B is exactly the same. We're starting over from the beginning. Okay. So the probability of black and red, red and black, go dogs, black and red. Alright? So the probability of the black ball is, once again, there's still 15. So we got 5 black balls out of the 15. Okay. Times, we've taken that black ball and we've set it aside. Alright, so now there's only 14 golf balls in the basket. But red, we still have 4 red balls because we took a black ball out. We didn't take a red ball out. So we can still have 4 reds. Okay. So that's the same as 1 over 3 times 2 over 7. Oh, so yeah, so that gives us 4 over 14. 2 over 7, which is the same as 2 over 21, which equals 0.095. Cool. Conditional probability formula. You'll have this on the quiz or the test, but it's the probability of A given B. That line up and down means given. That's the same as probability of A intersect B, or probability of A and B, over the probability of B. Alright? And so on these are the ones where we might have to use the table, or we might have to just look at our probabilities. Okay? So like number 11. Number 11. What is the probability that Susie works out given Susie loses weight on a diet? So, probability of Susan working out given Susie loses weight. Alright? So, just right now, before we do anything, we know that that's going to be equal, before we even keep reading, the probability of working out intersect losing weight. So working out and losing weight, okay, divided by, I guess it says losing weight on a diet, but whatever, divided by the probability of losing weight on a diet. Alright? So let's keep reading. If the probability of losing weight on a diet and working out, so that and tells us that we're going to be using this, looking at this top, the numerator, is 0.74. And the probability of losing weight on a diet, so that's the losing weight, is 0.81. So 0.74 divided by 0.81 is 0.914. Susie is probably going to lose weight. Highly likely to lose weight on this diet if she works out. Yeah. Alright. Moving on. Probability that the student completed his test review and passes math test is 7 out of 8. Alright, so that's that test review and math class. So that's probably going to be our numerator, right? The probability he passes math test is 9 out of 10. Find the probability he completed his review given he passed his math test. So probability of completed review given pass math test. Alright? So, going on with that. So the top is going to be probability of completed review, intersect, passed math. I like this kid. Over the probability they pass math. Right? So the probability they completed review and passed the math test is 7 out of 8. 7 divided by 8. Divided by the probability they pass the math test is 9 out of 10. Okay? That equals, if you are uncertain at all about plugging this into your calculator, first of all, I want to encourage you to use parentheses. Parentheses are your friend. It makes sure the calculator thinks what you're thinking. Or you can just do like 7 divided by 8 is get that decimal, 9 divided by 10 is get that decimal. But if you don't want to do it with the calculator, okay, so I'm going to put a parentheses and put 7 out of 8 in my top, divided by, open parentheses again, 9 out of 10 in the bottom. When I do that, I get 0.972. I like those odds. Cool. Moving along. Alright. So we're looking at high blood pressure in female. So the probability of random selected female registered in Villa has blood pressure is 0.42. The probability of random selected female with person would be a female with high blood pressure, 0.23. Random selected person would be female, 0.49. What's the probability that a random selected individual has high blood pressure? So probability of high blood pressure given female. Okay. So writing that out in our notation, that's the probability of high blood pressure intersect female, or high blood pressure and female, over probability female. So when we do that, the probability of high blood pressure and female will be a female with high blood pressure, right there, is 0.23. 0.23 over probability of female is 0.49. That gives us 0.23 over 0.49 is 0.469. Alright. Moving on, what is the probability the random selected individual is a female given that they have high blood pressure? So this is going the other way. Okay? So probability of female given high blood pressure. Alright, that's going to be the probability of female intersect high blood pressure over probability of high blood pressure. Okay? If you look, though, this female intersect high blood pressure is the same as high blood pressure intersect female. So this is still just 0.23 over now the high blood pressure is the 0.42. 0.23 over 0.42 is 0.547, 0.548. Cool. And so the cool thing about that is the tops are the same. See, 0.23, 0.23, 0.23. All right, moving on. I'll just have you know that these used to be a bunch of old consoles, but I updated them, so you're welcome. Anyways, so determine the probability of each of the following. It's 2,000 total gamers. Okay, so that's important. So the 2,000 total gamers goes in that corner. All right. So find the probability that the participant prefers the Sony PlayStation system. Okay. So we're looking at any age. So we got to find all overall who prefers Sony. Okay. So we're gonna add up the 63 and the 105, the 248 and the 191. Luckily, there's a little total box for us. 63 plus 105 plus 248 plus 191 is 607. So this is 607 divided by 2,000. All right. Gives us 0.3035. Cool. Moving on. Probably the participant is 25 plus and prefers the Xbox One. So this and it gives our intersect. Okay. So we're looking at where they overlap. All right. So prefer 25 plus is here. Xbox One is here. So we're looking at this right here. So we're just looking at our 166 over 2,000. Which is 0.083. Cool. Participant is 19 to 24 or prefers a Sony. So this is our union. Okay, so then we're going to look at probability of 19 through 24 plus probability of Sony minus probability of 19 intersect Sony. Okay, because that's the double counted. All right, if you think about it this way, probably 19, so we got to find our total number 19 to 24-year-olds. 248 plus 217 plus 83 plus 169 is 717. All right, 717. So what this is going to be is it's going to be 717 plus our Sony PS4s, which is 607. But then we're going to subtract out what's counted both, which is our 248. So we're going to subtract out 248. When we do that, this equals 1076. Then we're going to put that over our 2,000. That says 2,000 down there. And that is 0.538. So once again, what we did there is A, wrote too far over to the right so no one could see what I was writing. And B, we found our 19 to 24-year-olds total, which is 717. then our total number of Sony PS4s, and then we subtracted out the overlap, because the overlap was counted twice. Alright, moving on. Participate prefers Microsoft Xbox One given that the person is between the age of 13 and 18. So prefers MX1 given that they are 13. Alright. So this given, as soon as you see given, whether in a notation form or in a chart, is you need to go and only look at that column or row. Okay, so in this case it's going to be a row, and so I'm going to basically, like in my mind, block off this column, this column, this column, and this column. Rows. These are all rows. Block off every row except for my 13 through 18-year-olds. Okay, and so after I block everything off, I got to find my total of 13 through 18-year-olds. So I'm going to do 105 plus 139 plus 92 plus 113. So I'm just summing across here. It's 354. Alright. Sorry, I hit y'all. I hit the camera. So 354. Of those 354, 139 are Xbox Oneers. So 139 divided by 354 is 0.393. So the significant thing that I did here is because we said given they were between 13 and 18. So given that they were in this age group, what is the probability that they won Xbox One? And so I had to do in just this age group. So just out of these 354. It's not 354. I don't know how to add. I miscalculated my calculator. 105 plus 139 plus 92 plus 113. This total should be 449. Okay, which means down here is 449. Which means this answer should be 139 divided by 449.310. 0.310. Sorry, y'all. That's my bad. But yeah, so I just looked at this 449, and out of those 449, 139 of them were Xbox Oneers, and that's where I get 139 over 449. E is the same question. So given that they're between the ages of 13 and 24, okay? Between 13 and 24, that's two different groups, right? So the total between 13 and 24 is 449 plus 717, right? So that gives us 1166 of possible answers, okay? Then I'm going to divide it by the number of Nintendo Switchers in that area, which would be 92 plus 83. Okay, 92 plus 83 is 175. And then this way, 175 divided by 1166 gives us our 0.150. So if you didn't catch that, what I had to do there is because it said 13 through 24. 13 through 24. That's two different sections, right? There's two different groups that we're looking at. So then I had to sum my 449, my 717. Down here, I did that. Where's my pen? There's my pen, sorry. To give my 1166. And then I had to sum my Nintendo Switchers to go through like that. Alright. The participant is under 12 age given that they prefer the computer. Alright, so this is, we're only looking at the column that prefers computers now. Okay? Only looking at this column. Everything else is null and void. 51 plus 113 plus 169 plus 136 is 469. Alright, so it's 461 total people here. So I'm going to put 469 in the bottom. Right? And then I'm going to divide it by 51. And then 51 divided by that. So 51 divided by 469 gives us 0.108 or 0.109. So once again, I just summed up the total computer things, then had 51 divided by that. 51 divided by my 469. Cool. Last problem on this page. We're getting the home stretch, y'all. Congratulations if you made it this far. You are committed. All right. Out of the 45 students, 14 are taking Chem, 29 are taking English, 5 are taking both. Create a Venn diagram that represents the given situation used to answer the following questions. Okay. First thing first, I'm creating a Venn diagram. When I'm making a Venn diagram, work from your inside out. Okay? And so my very middle thing is this middle overlap thing. How many people are taking both classes? It's 5, right? So I'm going to put a 5 in the middle. All right? Then I'm going to move out to my outer circles. This will be my Chem. This may be my English. Okay, my Chem. 14 people are taking chemistry, right? But we already counted 5 of them. So we can't put a 14 here. I have to do 14 minus 5, which would be 9. So only 9 go in the only chemistry box, because the other 5 are also taking English. Same thing for English. I can't put 29 here, because 5 of them are already counted. So that means I have to put 24 here. Do y'all see where I'm getting that? That 24 plus 5 is my 29, but since 5 are already counted, I had to put 24 here. Now, what you have to look at is how many other students there are to get this section outside of the circles that are still inside our sample space. Because we know there's 45 total students, right? So, to count the number of people inside this circle, I'm just going to add 9 plus 5 plus 24. 9 plus 5 plus 24. And that gives us 38, okay? 38 people inside the box, inside the circle. So subtract that out. That gives us 7 people that are in the box that aren't in the circles, that aren't taking English, Comp, or Chemistry. Cool. All right. So all these probabilities, unless it has a given, which they don't, is going to be based on the whole sample space, or the whole 45, okay? So probability of E intersect C. Intersect E and C, that's that middle part here. So that's going to be 5 out of my 45, which is, of course, 0.111. Cool. E union C, okay? This is the one that gets tricky. So union is going to be probability of E plus probability C minus probability of E intersect C. Alright, so we can just look at numbers, okay? My number of E's is 24 plus 5, or 29 E's. 29 E's, right? Plus my 14 C's, 14 chemistries. 9 plus 5, or just up here. Minus the 5 that are taking both, gives me 38. 38 total people out of 45 is, of course, 0.84. 4. Cool. Moving right along. Probability not E. Okay? Probability E not E. How many people aren't taking English? Okay? What I'm going to do here is I'm going to do 45 minus 29. Because my 29 is people that are taking English. So everyone else isn't taking English. So 45 minus 29 will give me my not ears. Okay? So 45 minus 29 is 16. 16 out of 45 gives me 0.356. And that's my probability of not E. Alright? This last one, D, is kind of tricky. Okay? So, probability of not E. Alright, once again, we just said that not E, there are 16 not ears, right? 16 not ears. Plus the probability of not Chem. So there's 14 Chem students, right? So there are 31 students not taking chem. Okay. But then I have to subtract out the people that aren't in English and aren't in chemistry. So it's not going to be my middle section. It's actually going to be my outer section, because these are the people that aren't in chemistry and are also not in English. So then I'm going to have to subtract out 7. Alright, so 16 plus 31 minus 7, I think is 40, but I missed some math earlier, so let's check it. It was 40 out of 45, which is going to be 0.889. Cool. We're almost there, y'all. Alright, so going through 15 red plates, 7 blue plates, 3 red broken plates, 2 blue broken plates. Just information top. If the plate was chosen at random from the box, what's the probability of choosing a red one or a broken one? Probability of red or broken. Okay, so that's probability of red plus probability of broken minus probability of both. Red intersect broken. Okay. So probability of red is there's 15 red plates. Probability of broken, there are 5 total broken plates, but of those 5 total broken ones, 3 of them are red plates. Alright? So you got to subtract out the red broken plates. Alright, it's 5 plus 15 plus 5 minus 3 gives us 17 out of the 15 plus 7 total plates, out of the 22 total plates. I got 22 for just 15 plus 7. So 17 divided by 22 is 0.773. Plate is chosen random. What's the probability of choosing a blue one or one that's not broken? Probability of blue, okay, or not broken. Okay, so that's the probability of blue plus probability of not broken minus probability of blue not broken plates. Okay, so probability of blue, there are 7 blue plates plus probability of not broken. Okay, so there's 5 broken plates, right? So of the 22 plates, 5 of them are broken. That means 17 of them are not broken, minus the probability of blue and not broken. So there's 2 blue broken plates. That means there's 5 blue not broken plates. You see that? So 7 minus 2 broken gives us our 5. 17 plus 7 minus 5 is 19 out of 22. 19 out of 22 gives us 0.864. Cool. Final one. We're almost there. Go team. Alright. Probability of a hot dog intersection soda. So we look at our hot dogs and soda. There's 50 of them. Intersection means we just have to look at that one box. So 50 divided by 400 is 0.125. Probably a pizza union hot dog. Okay. Pizza union hot dog. So this is going to be our pizzas plus our hot dogs minus our both. Right? Pizza plus hot dog minus both. So pizzas, we have 182. Hot dogs, we have 158. 182 plus 158. Because we're looking at both foods, there's actually none that are both pizzas and hot dogs. So 158 plus 182 is 340. Divided by 400 is 0.85. We're doing it. Probably no food. This is tricky because it seems like it should be more complicated, but there's only 60 no fooders. Divided by 400 total surveys is 60 divided by 400 is 0.15. Probably of not soda. Okay, so there's 200 soda, which means there's 200 not soda. 200 not sodas out of the 400 total people. 200 divided by 400 is, of course, 0.5. I just got 400 minus 200 to get this 200. Probably water, union, no food. Okay, there's 140 waters plus no food, so 140 waters plus 60 no foods minus the 20 that are both. That gives us 180 over 400. 180 divided by 400 is 0.45. Probability of pizza, it's once again just simple, it's just 182 pizzas minus 400. Divided by 400. 182 divided by 400 is 0.455. I just found my total number of pizzas. Pizza given soda. So this is weight. Given. Slow down. Which one are we looking at? Alright. Pizza given soda. Okay? So given soda. So we're only looking at the soda column. There's 120 pizzas out of the 200 total sodas. So 120 divided by 200. 120 divided by 200 is 0.6. Then water given no food. Okay, so look at my no food people. Of the no food people, 20 requested water. So 20 out of my 60 no food gives us 0.33 repeating. And that is our answer, and that is the worksheet. I'll be here tomorrow morning. Send me an email when you get here, and I will, or send me an email if you want to come in tomorrow morning, and I'll say, come on. I'll be here during open campus, obviously. And yeah, good luck, have fun.